Okay, so welcome again to this week's session. So this week we're going to discuss the analysis or the description of data by means of analyzing the data. And today's session, we're only going to concentrate on the quantitative or numerical data instead of categorical data. There's not much that you can do with categorical data when it comes to summarization, where you're adding and calculating the mean and the median and the mode and the standard deviation. So it's only applicable to numerical data. So going to continue from where we left off. Okay, so by the end of the session today, you should learn how to calculate or find the mean, the median, and the mode, which are measures of central location. Or you need to be able to find the range, the variance, the standard deviation, and the coefficient of variation, which are the measures of variation or the measures of dispersion. And we're going to go into detail in describing each one of them. There will be some activities. Likewise, every week we do some little bit of activities as well to understand the basic concepts that we just learned. So this for 1610, 1510, and 1501, this will most likely be your study unit 3 information, where you're looking at analysis of data. We're going to cover two concepts today: the measures of central location or central tendency, which describes where your data lies or where the center of your data is at, and the measures of variation or the measures of dispersion, which tells you how spread is your data from the center of which is your average or your mean. So in terms of the measures of central location, we're going to look at the three measures of central location. In your module, you do not do geometric mean. I know that in some textbooks or some books that you might find in terms of basic statistics or introduction to statistics, they might also introduce more other measures. But for your module, you only need to know and learn about those three measures of central location. And for variation, you're only going to learn about the range, the variance, the standard deviation, and the coefficient of variation. So we're going to first start with the measures of central location. So remember our data set that we used every week. We're going to rely on the same data set, and we're going to increase it as we go along. But for today, because we're only going to be looking at numerical data, therefore it means our column H, that's the data that we're going to be using for the rest of the session today as examples. What is the mean? The mean is the most commonly used measure of central location. We calculate it by adding all the values, divide by how many they are. So you you take your values. It doesn't have to be sorted. So I will take the age values and then I will sum them or add them together and divide by how many they are. How many they are is by counting how many sample data set I have, and take that number, divide the sum, and that will give you your average or your mean. It's called the mean, or it can be called also the average. The mean is one of the measures that gets affected by outliers or extreme values. What do we mean by outliers or extreme values? They are values that are far away or far apart from the rest of the other values. For example, if I have 1, 20, 30, 40, 80, 100, 1, 20, 30, 40, 100. My 1 will be an outlier, and my 100 might also be an outlier because I've got 20, 30, 40. They are close to one another, and the two values are at the extreme ends, which are far apart from the rest of the value, whereas 100 might not be, but 1 might be an extreme outlier. So it will depend on how you define your extreme outlier in terms of the data set that I gave you just now. So that is what we call an extreme outlier, is the number that is far away from the rest of the other numbers. To calculate the mean, if we get the data from a sample, so it means you need to pay attention. You need to look at your question or your statements carefully and determine whether the information given is the population or is it the sample. To calculate the mean of a sample and the mean of a population, they are almost exactly the same. It's just that the formula looks different. So to calculate the sample statistic, which is the sample mean, we use X bar. So always remember, for the sample statistic or for anything that deals with statistic, with the sample, we're going to use letters that we know, which are letters of the alphabet. So for the sample mean, we're going to use X bar is equals to the sum of your X observation. X represent the observations that you have, divide by N, which is your sample size, which will be the number of the data points you have or the data values that you have. For the population, it is your mu, which is a Greek letter for mu. You just pronounce it like mu. It's mu. It represents big. So for population parameter, we use Greek letters. So mu is given by the sum of the observations satisfying the population divided by how many there are. So looking back at our example, we know that we have 20 sample data here, right? We counted it last time when we were visualizing the data. So there are 20 records on here. So that will be our N. So we're going to take all those values and add them all up together and divide by 20, and that will give us the sample mean. That's as easy as it to calculate the sample mean. If we were to calculate the population mean, we would take the sum of all the mean values, the age values, and add them together, divide them by how many they are, and it will be the same as the sample mean. So it will be 29.55. What is then the median? The median is the middle number. When your data is ordered or when your data is arranged in an order from ascending order to a descending order, from smallest value to largest value. If your data values, let's say at the moment I'm working with 20 data set, right? If your data value is an odd number, let's say it's 21. So I've got 21 data points. Then the median will be the middle value of those 21 data set. However, if your data set is even number or an even data set where like 20, the one that we are using, it's an even data set because it's got 20 values. Therefore, the median, we will find it by taking the average of the two values where the position is located or where the position lies between. The middle or the median, which is the middle value, will be in that position, in between two values. In order for us to find the median of the data set, it's easy when you have fewer data set. 5 data set, you are able to count or see that the middle value will be on there. So if I have 5 values, the middle value will be on position 5 when I order those values in ascending order. However, when your data is big, like 20 is huge, we're going to use the formula for finding the position. So to find the position first, because the position helps us to count towards where the median is. So remember, our data set is the raw data set of the age values from the survey. There are 20 of them. They were not sorted. When we find the median, we need to order the data. So we will have to order this data from lowest to highest. The other thing you also need to realize, remember, the mean is not affected by outliers. The median is affected by outliers. If there is an outlier, we will also use that to count where the position is at. So it is not, the median is not affected by extreme values or outliers. It's not sensitive to outliers because we are looking for the middle value, whereas with the median, we are summing all of them and dividing by 2, we're looking for the average. So with this one, we are going to just count where the median is at. So let's find the median of this data set. So first we need to order the data from lowest to highest. And once we have ordered the data, then we need to calculate the median position. How many data sets or data points we have? We have 20 of them. So 20 plus 1 divided by 2 gives us 10.5. Then we go to the data set and start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5 lies between two values. We're going to take 28 plus 28, divide by 2. If there were two different numbers, we will take those two different numbers and divide by 2. It's just that on our data set, we have 28 plus 28. So we'll take 28 plus 28. We're going to take the answer, divide by 2, and we will get the answer of 28. Therefore, our median value for this data set is 28. That's the middle value. Then other measure of central location is what we call the mode. The mode is the most occurring or most appearing or most frequent value. So the number that appears more than the other numbers, that is the mode. Not the highest number, but the number that appears more than the other numbers. It is also not affected by extreme outliers or extreme values because we are looking for the number that repeats more than the rest of them. We can use it either in the numerical or in the categorical data. So remember, in the categorical data, you are able to see the mode by looking at the category that has the highest frequency. Whereas the other, like the mean and the median, you cannot use that to calculate or to find in the categorical data, but the mode you can. So when we look at the mode, there are different types of data that you will get. You can sometimes get data set that does not have a mode. It means not any number appears more than the other numbers. So like 1, 2, 3, 4, 5. None of them appears more than the other number. They all appear one time. So there is no mode. Or there can also be several modes. So there can be a mode where there is one number that appears more than the others. There can be bimodal, where there are two numbers that appears more than the other numbers. So maybe probably 1, 2, 2, 4, 4, 5. So 2 and 4 appears twice in that data set, more than 1 and 5. So there you will have a bimodal. When there are two numbers, bi means 2. Bimodal means 2. Or you can have a multimodal. That is when multiple numbers have or are appearing more than the other number. For example, 1, 2, 2, 4, 6, 6, 3, 7, 7. So we have 2, 4, and the way I've counted them, appearing 3 times or more than the other numbers. 3 values appearing more than the other numbers. So that is multimodal data set. So let's look at our data set. So our data set, your data doesn't have to be ordered in ascending order, but it's easy if your data is ordered in an ascending order, then you are able to clearly see the pattern of your data. So in this instance, looking at this data, I can see that 28, 28, 28, 28 appears 4 times. And I know that 26, 26, 26 appears 3 times, and 27 appears 2 times. And you can do that to check how many times the others appear more than the other numbers. And when you realize, you will see that the mode is 28 because 28 appears more than the rest of the other numbers. You can also double check because 18, it's only 2 of them, and you can check the others if they appear more than the rest of them. But from this data set, only 28 appears more than 4 times in this data set. Okay, so that is the mode. Now, from the mode, the mean and the median, you are able to also tell the distribution of the data. On Saturday, we spoke about the distribution of the data looking at the histogram. So let's say we're not building a histogram. You can still look at your mean, your median, and your mean and your median to look at the distribution of the data. And that will tell you whether your data is symmetric or is skewed. Now, when your data is left skewed, therefore it means the tail of your data will be to the left. That will mean that the mean is less than the median. If your data, your mean and the median are equal, if they were 28 and 28, then we will say our data set is symmetric. If it's right skewed, or what we call positively skewed, it means your mean and your median. So it means your median is less than your mean. So it means the mean is greater than your median in that instance. So the mean will be bigger than the median, whereas on the left skew, the mean is less than the median. So you need to remember that. So if we look at our data set, remember, we found that the mean, our mean was 29.55, and we found that the median was 28. So in this instance, our data that we are working with, our mean is greater than the median. Therefore, we're working with positively skewed data because our mean is bigger than the median, or the median is smaller than the mean. So therefore, it is right skewed or positively skewed. And this side, we say it is negatively skewed. And that is because the tail tends to go to the negative side. And this side, the tail goes to the positive side. So always remember that. Okay, so I can just do all of them at once. Now we're moving on to the measures of dispersion. Remember, if you have any question, please feel free to stop me at any point and ask. Your measures of dispersion are the range, the variance, the standard deviation, and the coefficient of the variation. So when we talk about the range, we also did mention this when we were building the frequency distribution table. So the range is the simplest measure of variation. It tells you the difference between your highest value and your lowest value. It gives you the dispersion of your data set. So from our data, we need to also sort the data from lowest to highest. And from there, we are able to identify our smallest value and our highest value. So we're going to take our highest value minus our lowest value, and that gives us the range of the data. So that means our data set is dispersed, or there is a variation of 27 between the smallest value to your highest value. The other measure of variation is the variance. Usually, the variance, you don't have to explain it because your variance is just the average of the squared deviation of the values from the mean, which normally it just tells you the dispersion between your values to the average or the mean. It provides a measure of total deviation from the mean for all observation, and you can calculate if the data comes from a sample. We calculate the sample variance by using this formula. S, remember the sample statistic is S squared. We use the normal alphabetical letters, which is S squared is equals to the sum of your observation minus the mean squared divided by n minus 1. And for the population, we use sigma is sigma squared, which is the sum of your observation minus the population mean squared divided by the population's sample size. The only difference between the sample variance and the population variance is in the n. With the sample, we use n minus 1. With the population, we use n. I'm not going to do an example with the variance because I'm going to introduce the standard deviation, which is the square root of your variance. So if you take your variance and put the square root, you calculate the standard deviation. And here, it shows you the variation about the mean. And because of that, we are able to interpret the values of the standard deviation when we can interpret the values of the standard deviation because when we're doing the calculation, we take it back to the same unit as the original data set. By squaring the answer of the square root, it also normalizes your data. So the formula for the sample standard deviation, which is your sample statistic, S, is equals to the square root of your variance, which is the sum of your observation minus the sample mean squared divided by n minus 1. For the population parameter, we use the population standard deviation, sigma is equals to the square root of your summation of the observation satisfying the population minus the population mean squared divided by the population size. An example. So looking at our data set, right? It doesn't have to be sorted. We have calculated the mean. We found that the mean was 29.55. We counted how many there are. There are 20. We're going to use the sample standard deviation because we are using the sample data because in the beginning, we said this is a sample extract from the survey, right? So we're going to use the sample formula. Substituting, it means we're going to take each observation, subtract it from the mean, square the answer, add the next one, square the answer until we exhaust all the data at the top and divide everything by n minus 1, which is 20 minus 1. So we say 45 minus the sample mean squared plus 36 minus the sample mean squared plus 37 minus the sample mean squared plus 28 minus this until we get to 35 minus the sample mean squared divide by 20 minus 1. And when you summarize the top part, you get 1076.9504 and some number. I'm keeping only 4 decimals. Divide by 19 minus 1. Oh, sorry, 20 minus 1 is 19. When you simplify everything and take the square root, the answer is 7.53. Everything underneath the square root, if I take this value, 1076.9504 divided by 19, this value here, it is your sample. You will get the answer to the sample variance, because when I take the square root, I will find the sample standard deviation. Okay, so that is sample standard deviation. The coefficient of variation is also another measure of variation, but it's always represented in a percentage format. And this shows your variation relative to the mean. Whereas the others was variation to the mean, this one is variation relative to the mean. And we can use it to compare two values. So let's look at our example. We know that we had the mean of 29.55, and we had the standard deviation. We calculated the standard deviation and we found that it was 7.53. That's what we calculated here, standard deviation. So we can calculate the coefficient of variation, and that will be 7.53 divided by 29.55, multiply the answer by 100% or 100. You can just say by 100, still fine. And the answer will be 7.53 divided by 29.55 equals, and the answer multiplied by 100 is 25.4822, which I can leave it in 2 decimal, will be 25.48%. And it tells me that there is a huge variation between the age values of 25.48. And that concludes our session for today. But before we leave, there are many other simple ways of calculating everything that I just explained, right? The same data set, you can take it to Excel and calculate using the data panel. And on the data panel, there is a data analysis add-in that you need to add to calculate the descriptive analysis. And when you choose that descriptive statistics, it will give you a summary of the data in this format, and you are able to see all those values that we covered today. It gives you the mean, the median, the mode, the standard deviation, the sample variance, and the range. At this moment, you do not need to worry about the standard error, the kurtosis, the skewness. You can also look at the maximum and minimum and the sum of the values and the count if the questions in the exams are asking you to look at that. You can also use a sharp calculator to calculate your descriptive statistic. You need to know the steps. They are easy, but you need to practice and practice and practice in order for you to know how to use your calculator and feel comfortable to use your calculator for when you get to go to write your exam. You can also use a Casio or a sharp calculator, or your scientific calculator, your financial sharp calculator. You can use your HP calculator. You just need to know how to use it, and the steps are there. I might have missed 1 or 2 steps, but these are more or less the steps that you will have to follow in order to answer the same questions if you get them in the exam. I know that we are running out of time. We have 20 minutes. So let's see the type of questions you get in your assignment or in the exam. So we're gonna go into activities unless if there is a question. Let me see. Are there any questions or comments? Let me also look at the chat. There is nothing. Are you good or are you happy?
Lizzie?
Yes.
So you see, when we start calculating, you said we need to go literally 28 plus 28.55, like all those lines. What happens if the data range is a lot? Like we have a data set of 20, so it's, yeah, here. We have like a data set that's just of 20, but what happens if we have a data set of 100 or 1,000?
Okay, so okay, let's take it this way. In this module, they will not give you 100 or 1,000. They will give you 20, 30, 50 in the assignment because you have time, right?
Okay.
So what I will suggest you do, especially when you get to the formulas like this, do them step by step. Write the formula out like I've written it. Calculate every value, write the answer. Every value, write the answer, and then add all the values and write your answer there. That's how you can resolve your questions without any challenges. Otherwise, yeah, but okay. To tell you the truth as well, in the exam, they will not give you a 20 data set like this because in the exam, you are writing against time. So they will give you a data set with 10 or 15, or it will be a small data set, maybe with 6, 10. I think maximum is 10 or 12. It will not be more than that. It cannot even be 20 or 30 because you are writing against time. But in your assignment, it means you have all the times. Unless your assignments are timed, then you cannot complete it on time. But I'm hoping that your assignments are not timed, so you are able. They give you ample time that you can spend more than 3 hours on your assignment to complete if they give you a big data set. But they can give you in the assignment more than 20.
All right. Thank you, Lizzie.
Okay. Okay, so let's look at some of the questions that you might get. Sometimes you will get questions where you need to calculate. Sometimes you will get questions where they need to test your understanding. You need to know theory and calculation in statistics. You cannot just know how to calculate. So question number 1. What is the observation that occurs most frequently in the data set? Is it number 1, number 2, number 3, number 4, or number 5? I'm asking you. That's a question.
Number 5.
It is number
5.
5, which is the mode. The mode is the number that appears more than the other numbers. Sometimes, based on the information that you've learned previously, they can also ask you questions based on that information. For example, you know this graph, right? This chart is it represents a stem and leaf plot, right? And we know that a stem and leaf plot is a numerical data where the first value is 25, the second value is 26, and the last value is 61. So based on that knowledge, you should be able to look at the questions asked and look at the data set given and be able to respond to those questions and apply measures of central location or measures of central tendency or measures of variation questions on that. So we are told that there are 40 workers here. Which one of the following statement is incorrect? So we're looking for the incorrect statement. The first one says, and always remember that you need to look at your your stem and leaf plot, that they have ordered it. It should be in an ordered array from ascending order, especially the stem, the leaves. They should also follow an order. Also, the leaves and the stem should also follow an order. So you cannot have 2, 4, 3, 7, and 10 haphazardly. So they need to be in order. So which one of the following statement is incorrect? So we can do a process of elimination because we are asked for the incorrect statement. What is the smallest age?
25.
25.
The smallest,
25 is
the
correct.
smallest age is 25. Therefore, this one is correct. Most age in the sample are greater than 40. Here
Correct.
is 40.
It's incorrect.
It
Not
is
correct.
It is not correct. It says most ages in the data set are greater than 40.
It's not correct.
How do you know that it's not correct? You can count how many ages are greater than 140, are greater than 40. There are 1, 2, 3, 4, or greater than. It means it doesn't include 40. We're not going to include 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 of them that are greater than 40, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I'm going to 16 and above, it means most of them are less than 40. So this is the incorrect. Because it said greater than 40. The mode of the distribution is 41. The number that appears more than the other numbers, is it 41?
It's correct.
That is
Right.
correct because 41 appears 4 times. The range of the data set is, or of the distribution is 36. How did they find the range?
The highest number minus the lowest number.
So it was
61
61
minus
minus 25.
25.
And that will give you 36.
Yes.
That's how they got it. So that is correct. The median is 38. So we can find the position, which is at n plus 1 divided by 2. We are told that there are 40, so it will be 40 plus 1 divided by 2, which is 41 divided by 2. It's 20.5. 20.5 and 20.5, it means it lies between 20, position 20 and position 21. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.5 lies between those two values, which is 38 and 38. So the median is 38, because 38 plus 38 divided by 2 will just give you 38. And that's how you will answer the questions when you get them in the exam or in your assignment. That's how easy it is. So do not panic when you see a data set that looks like this and is not in a line row data type of, and it is in a stem and leaf plot. You can take the stem and leaf plot and convert it to the normal raw data that you know of. This is just the visualization.
Sorry, Lizzie, if I may
Yes.
ask, so
Yes, you may.
if number 5 was the medium is 37, we were going to count until 7.
If it was 7.
37, for example.
If the position,
Yeah.
yes, if the position was 37, so if the position here was 37, you would count until you get to 37 and then you stop right there and you say that is your median. So let's say it was 20. So you would have said if the median was 20, we would have stopped there. Or if the median was 19, we would have stopped at there.
Okay. All right. I get it. Thank you.
Every time if it ends with 0.5, it means it's between two values. It is closer to or above, so it will be between the two values. If it's a whole number, for a whole, if the position is a whole number, the position will be on that whole number. If it's a decimal of 0.5, then it's between two values. Later on, we're going to be doing the quartiles. We're going to apply the same principles. So you need to be aware of these things and remember them all the time. Okay, so we are right on time. The distribution of the following data 42022 is. Now, the question is, you need to tell them the distribution of this data set. How will I know the distribution of this data set? You need to calculate first the mean and the median, right? Those are the two things that you need to calculate. Always remember, I'm going to put them here so that you can always remember those things. If the mean is less than the median, then we say it is negatively skewed, right? If the mean is equals to the median, we say it is
Symmetric.
symmetric. If the mean, I'm always going to use the mean. If the mean is greater than the median,
Positively skewed.
we say it is positively skewed. So those are the things that you need to remember when you're looking at the data set or you're looking at your data. Now, the mean, easy to calculate. Remember, it's the sum of all observation divided by how many there are. It means adding all of this number. 4 plus 2 plus 0 is 6 plus 2 is 8 plus 2 is 10. So 4, 6, 8, 10. So we have 10 divided by how many there are? 1, 2, 3, 4, 5. Remember, 0 is also a number, right? You cannot discard it. 0 is also a number. So then the mean is
2.
2. The median, we're going to find the position first. So let's go find the position. N plus 1 divided by 2. There are 5. So it's 5 plus 1 divided by 2, which is 6 divided by 2, which is 3. But we need to order this data set is 0, 2, 2, 2, and 4. The median is the middle value. 1, 2, 3 is 2. So what is the answer to the question?
Symmetric. The answer is symmetric.
The answer will be option 1. So you see how you can answer the question. Sometimes the questions might be as complex as this, or they can be as straightforward. So this is one of the complex questions, because if you don't know how to find whether this data is symmetric or skewed, you will scratch your head and you will panic. Whereas now you know, in order for you to test whether the data set is symmetric or skewed, you need to first calculate the mean, you need to calculate the median, and check whether any of those are equal or greater than or less than each other. and you come back and you answer your question. Even though it's multiple choice questions, but there is some work that you need to do before you can answer any of the questions. Okay, I'm not going to do this exercise because the data set is huge and we're left with 3 minutes. We can talk about it. You can take a screenshot of it, and then you can go and do the activity on your own, and you can discuss with your classmates or validate via the WhatsApp group. So on this data set, you are given 10 autonomous vehicles at Tesla, and they're asking you to check which statement is incorrect about the measures of central tendency. And these are the production costs. Number A is asking you to find whether the distribution of this data set is positively skewed or negatively skewed. So therefore it means the same exercise we did previously, calculate the mean, the median, and come back and test this. Number B, they are asking if the mode of this data set is 1,263, you will have to go to this data set and look at if there are any number that appears more than the other numbers, and then select that number. The median, you will first have to find the position n+1 divided by 2, and then go and find the position, the median value. And the median value will be 1,263. Therefore, it means before you do that, you need to sort your data as well. The mean, remember, it's just the sum of all observation divided by how many there are. You just add all of them and divide by how many there are. There are 10 of them. So you just add all these values and divide by 10. And you should be able to check which statement is incorrect. The last question, also you can do on your own. And here, because we didn't touch too much on the coefficient of variation, but this one also is one of the questions on coefficient of variation. You need to be able to answer the following. So I'm going to say ignore number 2. If you don't get it right, it doesn't really matter that much. But just make sure that you are able to answer question number 1 and question number 3. So remember, the coefficient of variation, which is CV, it's given by the sample standard deviation divided by the sample mean times 100. So if you are able to answer those 2 questions, it will be great. And you should be able to also answer number 5. You are looking for the incorrect answer. And my ticks don't say, so you can ignore number 4 and number 2. They will not influence you. You should be able to answer this question and get the answer, the incorrect answer, by only looking at number 1, number 2, and number 5. On Monday, the following, on the 24th, we are going to touch on the interquartile range. And therefore, when we do that, we will bring back this question again and see how we can answer it with relation to those 2 questions. Other than that, thank you for coming. That concludes today's session. There is another question, or question number 6, that you can also go and do on your own. Which one of the following statement is correct? So yeah, we're looking for the correct statement with regards to coefficient of variation. See if you remember what we just spoke about. This question is only asking you if you know that what coefficient of variation formula is. You should be able to answer that question. You should be able to answer that question. So always remember, in your module assignment or exam, you get questions that are theory, get questions that you need to do calculations. You need to learn both. Therefore, it means you need to be sure that you know your study material when you go write the exam. Okay, so by the end of today and by the end of the sessions that we do this month, you should be able to answer your assignment 1 questions and get 100% with ease, probably, because we would have covered everything you need for your assignment 1. Other than that, just a reminder, on Saturday, we're going to look at empirical rule. Probably I'm going to also squeeze in how to use your calculator to calculate the mean and the standard deviation, because we need those two in order for us to calculate the empirical rule. On Monday, we're going to close off the analysis of data, part 3, by looking at the quartiles, the box plot, and the percentiles. And that will be your study unit 1, 2, and 3 done and dusted. And what would be left will be you practicing and finding more activities to do on your own. Other than that, remember always to sign up for sessions using the Calendly I've shared with you. Those who joined via or who saw the invite via the Facebook messages, also the link will still always be there. Make sure that you sign up for every session. Every session you need to register so that you can get the Teams link. Those who join via the WhatsApp group also do likewise. Please make sure that you register for those sessions. Always, I just want to end by introducing those who don't know who I am and what we do. I don't work for UNISA. I work for Phambili Analytics. I do the sessions, the online sessions, for free, because one of my mission is to see as many people become more data literate and love and fall in love with statistics and research and data, so that they can become more data literate and more and close the gap in terms of analytical skills that exist. We must remember that data is our new oil. With technology, the possibilities are all there. Now we're talking about AI, ChatGPT, and all that. Don't be left behind because you lack the skills. We are here to support you in order for you to achieve those little skills or smaller skills or minor skills that will also build your career as well. That's where we are as Phambili Analytics. Some of the services that we offer, not only to individual in terms of skills development, which is our main area of focus, but we do offer data analytics consulting to small businesses. We do data science consulting work for people. We do research. If you know anyone doing master's, PhD, or research for work and they are struggling with their research, we help with the research work as well. Our trademark, which is our skills development programs, we do offer instructor-led training, which is similar to what we're doing, but because this one are hyped up 1-hour sessions, we do have the one-on-one instructor-led training that we do virtually or face-to-face in person, or you can opt to take the self-led online training, which I would not suggest you do for statistics, especially while you are studying with UNISA, because then you will be repeating what is sitting on your My UNISA system. So I will prefer, if you want to take up this one, then take up a data literacy or a R programming or something, one of the courses or training courses that we do on a self-paced or self-guided learning. Otherwise, what I also need to bring to your attention is that even though the sessions are for free, we do have a special 150 per hour, which is a discounted price from my rate, which is 350. So you can sign up per hour, or alternatively, you come and attend all these free sessions. But there is a catch. You need, in order for you to be able to access the recordings or the notes, you need to join and subscribe. Or you need to subscribe first, which is free of charge. You can watch any ending videos that are published on the site, on the YouTube site. Always remember to put the clocky so that you can get notification when new videos are uploaded. Most importantly, please join the channel. Help me build more by becoming a member of this channel, and you can cancel anytime. Feel free to cancel anytime you want. Only members who join using loyalty, appreciator, and promoter will have access to most of the videos. And those who sign up as loyalty, you will get the HTML link to the notes. Those who join as appreciators and promoters, you will get more than what the others get. If you join as a supporter or cheerleader, thank you very much for your support and your contribution. It goes a long way. And I would like to also, while I'm at this point, give a shout out to the following people: Jeanette Zizal, for being my cheerleader and my supporter; Knox Klengwa, for your loyalty; Brownwin Pepperell, for being your cheerleader; and Renee Craig, for becoming a supporter. I really appreciate your contribution. Will go a long way. And it will also give me strength and energy to continue doing what I do, and probably maybe even offer more free sessions to other students. On that note, thank you for coming. If there are any questions, comments, anything else, you can send an email or WhatsApp, or go to our website, as well as visit our YouTube channel. Thank you for joining.
Thank you, Lizzie. Bye.
Bye.
Thank you. Bye.
Thank you. Bye.